fifth plus x to the fourth.
One second. I'm having a little bit of a background noise issue here. Go ahead again.
It is negative 2x to the fifth plus x to the fourth plus x cubed plus x squared.
I missed the
I know exactly.
After the x to the fourth, what is it?
So
Plus x cubed plus x squared.
Do you hear that background noise?
That's my mom on the phone.
Oh, that's your mom on the phone. Okay. Well, I thought maybe that was some sort of an interference that I was only hearing on my end.
You're having the powers of attorney.
Okay. And this is equal to?
No, it's like over. We're dividing it.
Okay.
By negative 6x squared plus 14x plus 20. And she asked us not to solve it with synthetic.
Not to?
Not to.
Meaning she wants you to do it by long division?
Yep.
Okay. Let me look at it a second. This is an odd problem. But I frequently get odd problems from honors students. Let's see. We can factor the top. It's still going to leave us a cubic. Then we could divide into the cubic, perhaps here, but maybe there's no reason to even do that. Let's go ahead and do long division. Let me do it this way. I may not have enough room if I write it like that. Let me do it this way. Do you know how to do long division?
We briefly went over it.
Yeah, as long as you're not missing any degree,
So you want to set an
you
appointment?
don't need to put in any dummy variables.
Okay. Well, I'm not really working this week, but next week, do you work? Is there a day of the week that's better? I do one Tuesday evenings. I work late.
Okay, the very first step is to divide that into that. Now the question is...
Oh, okay. So Tuesday I have 4 o'clock on Tuesday the 1st.
I can
Or if you want to go.
factor something out of that first. Well, let's do this and use fractions. The way you do long division is you divide the first term into the first term. That's all you care about.
Well,
So what do I get when I divide minus 2x to the fifth by minus 6x
squared? A questionnaire that you would take a stab at before you came in. I have not completed it all the way, but it would just kind of frame the discussion a bit.
See how I got that?
Yeah, I see.
Okay.
Is it
Now, you take this term and you multiply it by each of these 3 terms. And you do it just like you were doing long division with numbers.
Okay.
So when I multiply this back together with that, I better get that same thing. I do. Now hold on. Excuse me.
And what's your
I'm
phone
going to
number?
multiply that by that. So I get plus 14.
Do you know where my office is located?
Third x to the 4th. And multiply it by the number, and I get 20 over.
I'll put that in an email directions thing.
And now I subtract, just like I normally would. In other words, this term always goes to 0. And then what I'm doing is subtracting the bottom row from the top. What's x to the 4th minus 14 thirds x to the 4th?
On December 1st. And doesn't work out,
negative
let me know. You'll have my email.
4 2/3 x to the 4th, or would I just leave it as 14/3?
Well, it's not quite that. In other words, I have 1 minus 14/3, right? How do I do that now?
Yeah, we're all struggling.
I don't know.
Well, turn this into a common denominator. So it's 3/3
Yeah.
minus 14/3, which is minus 11/3. So
Right.
it's minus 11/3 x to the 4th. Subtract over here. What's x to the 3rd minus 20/3
I know my
x to the 3rd.
do that. They just prefer they might bypass family entirely and just go to charity. So we do
Minus 17 x to the 3rd.
Minus 17/3 x to the 3rd. And now we bring down the next term, just like long division with numbers only. And now repeat.
Exactly.
Okay, and so divide again. In other words, start over. The only thing you're worried about is dividing that into that. So what's the next term up here? Plus or minus?
Excellent. I'll get that over to you.
Plus, minus.
What's 11/3 divided by 6?
I don't know.
11/18. In other words, if I'm dividing by 6, I'm just putting 6 in the denominator.
Absolutely.
And it's x squared, right?
Mm-hmm.
Okay, now I do the exact same thing as I did the first iteration. I multiply that term by all 3 terms. Well, clearly if I did my division properly, this first term is minus 11/3 x to the 4th. In other words, when I multiply that by that, I better get the same thing as I got when I divided that into that, right? Okay, now multiply this by this. This seems awfully tedious and fraction-y. She didn't teach you some trick to avoid all the fractions, did she?
She left halfway through the lesson.
What's that?
She left halfway through the lesson.
Okay. Well, this should work. We may end up with a fractional remainder, or and having these fractional coefficients is not really a problem. So let's finish multiplying. So 11/18 times 14 is 154/18. X to the 3rd plus 220/18 x squared. You kind of get the idea? Not sure we need to do the rest of this. It's going to get more and more complicated as we, well, maybe not. Hold on a second. There's nothing else to bring down. So this actually may be the final step. But she was in the middle of doing this problem and she got sick or something and had to leave class?
No, the calculus math class next door had a sub, and the sub didn't know how to teach something, so she went in.
Okay, I got you. All right. So let's subtract again. In other words, we're subtracting this minus that, and that's always going to be 0. We're taking this minus that. Well, that is 100 and, let's see, if I multiply top and bottom by 6, I get 102. So I have minus 102/18 subtracting 154/18. What is that? 52/18? I'm not going to reduce for the... No. I got to add the two numbers together.
So it's 256?
Yeah. 256/18 x to the third. And subtracting this, let's see, that's 18/18 minus 220. So that's going to be 202/18 x squared. All right. Now there's nothing else. I guess there is. There's nothing else to bring down. So now we have one last step. 1/3 iteration. Divide that into that. And that's going to give us our last polynomial. I suppose we could end up with a constant. Yeah, we could end up with a constant, but there's no constants in this, so we're going to have just a remainder after this term here. Okay, dividing that into that, it certainly gives us some number of x. What is it? It's 256 over 108. 6 times 18, x, okay, and I multiply back, so that's 256/18 x cubed. Multiply that times 14x. Gotta be kidding me. X squared. And then the last term here is plus 5,112 over 108. And that's just, that's x. We did need a blank, a ghost coefficient. See what I just did there?
Mm-hmm.
In other words, you have to have every degree of your polynomial represented. And I may even need to add a 0 for the coefficient that's missing. But I definitely need to add a 0x and bring it down. And when I brought it down, it became that. And now I can do that subtraction. And the subtraction is, I can do it over here. It's easy enough to do that one. This one here, I don't know. Do you care what these numbers?
Not really.
Okay. It's x squared. I mean, we don't need to do arithmetic here. I got to multiply 14 by 256 and subtract that from 202, and that's the numerator.
That's, 14 times 256 is 3584.
Is what?
3584.
3584. Okay.
And minus 202.
Add 202 to that. So that's minus 3786 over 18 x squared. In other words, after I subtract that from that, I have this number down here. Okay? And I guess there's one final step. In other words, since I keep doing this until I can no longer divide minus 6x squared into this. In other words, after the next step, I'm not going to be able to do it anymore, and I'm going to have my remainder. And my remainder is going to be some polynomial divided by that. But I still can do one more division. In other words, if I divide minus 6x squared into this first term, I don't have any more x squared. I get just a number. And that number is minus 3786 all over 6 times 18, 108. Now, that's the polynomial that is the answer. But if I multiply this number by every term here and do exactly what I had done, if I get 0 for an answer, then I don't have a remainder. If I don't get 0 for an answer, then I do have a remainder. And it will be whatever I have left after this last step. The arithmetic is just getting too silly to keep doing. But notice that I am going to have a remainder because I have to, at a minimum, multiply that times that number. And it's not going to cancel and go to 0. So I'm going to end up with, at a very minimum, a constant. And I won't be able to divide anymore. So whatever I end up with is my remainder. The remainder is always a polynomial that is a lesser degree than this polynomial. And the denominator of my remainder is your divisor. Okay? Now, I can't even understand why she gave you this problem other than to illustrate the fact that you need to put a dummy coefficient in for x. Don't know that we really need this dummy coefficient. Let me think for a moment. See, I could have factored this a little bit, but I couldn't factor it any more than getting this coefficient down to 3. Okay, if I could have gotten it down to 2, I would have done it, because it would have made that first step non-fractional. But I don't know how you get away from fractions here. There's just no getting around the fact you're going to have an answer that has fractions in it.
I have no clue. We didn't do one fraction problem in the notes.
What's that?
We didn't do one practice like fraction problem in the notes.
This is not a good first one to do. If you're trying to learn how to divide polynomials by polynomials, this is like dropping you off from a helicopter on Mount Everest and saying, learn how to ski. This is not where you begin. Okay, you start out with simple ones. Maybe a quadratic divided by a linear or something. You know, you don't have to use synthetic division, but is all synthetic division? Duh, I'm not even sure how to use synthetic division when you're dividing by a quadratic. I know how to use, I do not know how to do that. Maybe that's why she said don't use synthetic division, is because you can't. In order to use synthetic division, I believe this term has to be linear, like an x minus 5 or something like that. And then you can just divide by the number. Or it can be complex, a plus bi. I know how to do that synthetically. But I do not know how to synthetically divide by a quadratic. But I do know how to do it by long division, and it's this way here. I'm trying to think, does it help any If we factored out an x squared, it might make the arithmetic a little easier. In other words, then we would be, yeah, you know, it would, actually. I should have done that. In other words, instead of dividing this quadratic into this fifth degree polynomial, had we factored out the x squared, we'd have been left with a third degree polynomial. And then we would have only had to do 2 steps instead of the 4 steps that we actually did. Now we got 7 minutes here. Let me show you what I'm talking about. Why it would make the problem so much easier. In other words, the new numerator is going to be this. So I'm always going to have that as a factor, so I don't need to do anything with that. But now I'm going to divide this quadratic into this cubic, and there's only going to be a couple of steps. Huh, interesting. I don't need to use a ghost thing either. I guess the moral of the story is that you should always factor when you can factor. And in fact, let's factor out a 3 from the bottom. The smaller numbers we make it, the better off we're going to be. We're going to let the bottom be this. I didn't do this the first time because I thought she wanted you to do it by long division without doing anything else first. Whoops, I can't factor out a 3. I can factor out a 2. What am I thinking? Factor out a -2, and that leaves 3 there. Now let's factor out a +2. Just not to confuse things. That leaves 7x plus 10. Okay. Now we've made the problem a little bit easier. Our fractions aren't going to get out of hand quite as much, and we don't need to worry about a dummy variable. What's this first term?
2/3?
Yeah. So all we're doing is we're dividing this first term over here by this first term. In other words, I'm putting it under there and doing that division. Okay? And that's what, and I get 2/3 x. Now I'm going to multiply that by every term. Well, we know that the first term is the same. We got plus 14/3 x squared plus 20/3 x. Now the math is a little easier. And I'm only going to have 2 steps. Subtract, that goes to 0. This still becomes minus 11/3 x squared minus 17/3 x plus 1. Now I got one more step, and that's to divide this into that. What's this term? 11/9.
11/9.
Yeah, I'm dividing 11/3 by -3.
Oh.
Okay, and the x squared goes into the x squared even, so that's my constant. Now I only have one more step. Multiply it back, get that. Multiply that by that, I get 77 ninths x plus 110 ninths. And now I can do subtraction, and I have my remainder. Perfect. Okay, these cancel. This minus that is 51 minus 77 is minus 128 ninths x. 9 ninths minus 110 is minus 101 ninths. That is your remainder. So the answer is plus that remainder minus 128 ninths x minus 128 ninths x minus 101 ninths, all divided by the divisor minus 3x squared plus 7x plus 10. Now, this isn't quite the answer because I factored out the x squared and the 2. So my answer is really that times x squared over 2. There's your answer right there.
Oh, okay.
Not sure exactly why anybody would give you this problem, but I guess you can see that it was a lot easier after I factored, as opposed to doing the division before factoring. I had like 5 steps and the fraction just kept blowing up, whereas this way I only had 2 steps and the fractions stayed manageable. All right, Julie, you good to go? And let's see, this is going to be our only session this week. I think I did not. Oh no, I got to take it off for Wednesday. Let me do that real quick. Cancel that one. And I guess I will talk to you a week from today.
Okay.
Okay, have a good week. Happy Thanksgiving.
You too. Bye-bye.